So let's start talking about some terminology with data mining. The first one is, what are we mining? The best learning for data mining is to start with an example and explain the terminology as we go through an exercise. The data mining in this example will be to look at customer bike buying. Once we have a model, we can try to predict which attributes of a customer are most likely to influence the buying of a bicycle. The data is very important. If you are coming from a relational database skill set, denormalization may seem a little against the grain for you, but data mining works best with a flattened data set in a table or view. In our case, we're going to use a view, which is a join of a series of tables. That does not mean that you can't use related tables. You can use related tables and relate them in the model if necessary. The model we used is determined by what we are looking for and the available items needed to use this mining model. In this case, we're going to use a decision tree to examine the data. We can use this model because we have a key to the view, attributes that are continuous and discrete, and a column to indicate 0 for someone that did not buy a bike and 1 for a person who did buy a bike. There can also be a case where this column is null, and the model handles that as well. The bike buyer view is a flattened structure of data from a fact table and related dimensions like customer and date. In this example, you can see part of a view that was used for our data to be displayed in the data mining model. If you look at the from clause, you'll see inner joins to the dimensions date, product, subcategory and category, customer geography, and sales territory. And then you can see in the select part where we get the category name from the category dimension. We also can look at model name from product, and you can see that C.customer key is the key from the customer tables. Now there's going to be one more view that actually looks just at bikes, or the category bike, that uses a subset of this data. So let's look at the data a little more closely. Examining the data, we can see different characteristics to attributes. A column of data is discrete when there are values but no real order to the data. Here you see the column and a distinct list of English education, which is high school, partial college, graduate degree, and bachelor's. There are cases where data has to be discretized, like age, where you want bands to group the ages. The continuous data set is like yearly income, that you want orders in the value. Here you see a display of distinct yearly income ordered by yearly income, and that's what the model will look at if that algorithm can handle a continuous flow of data. The key in this case is the customer key or the buyer key. This test of a group by with having count is greater than 1 can show that there are no duplicates in this view, and that not having duplicates is a requirement of the key value for the decision tree algorithm. The last column is the predict column. In this case, it is 1 for bought a bike and 0 for not buying a bike. There can also be a null value, which is an unknown if the person bought or did not buy a bike. The bike buyer example can use the Microsoft decision tree to predict a bike buyer. For example, in a model defined to use the Microsoft decision tree algorithm, you will define a key field that uniquely identifies each row or case, which was our customer key, the input values like yearly income, number of children, and age, and the predictable value, which is the column bike buyer. You can determine which customers will respond to a certain ad based on the demographics of prospective customers compared to the demographics of previous customers. You will define and train your mining model based on the responses from the previous buyers. Last, the clustering in naive Bayes can be added to an existing data mining. The key, attributes, and predict column will carry over, but attention needs to be paid to what was deselected. These items do not get selected because of the type of data used in the column. Let's look at a demonstration on creating a data mining model. First, we're going to launch SQL Server Data Tools. And once the application is launched, we're going to create a new project. It's going to be a multi-analysis services, multi-dimensional, and data mining project, which is the top selection in our choice. Here in the Solution Explorer, we're going to need to first create two things. The first one is going to be our data source. I'm going to right-click on data source and create a new data source. Click the Next on the welcome screen and create a new connection. I'm going to put the period for my local instance and select the data warehouse for AdventureWorks. Then I'm going to click OK and click Next. In the impersonate information, I'm going to tell it to use the service account rather than hard code an AD account in the password. Then I'm going to click Next. And we'll give the data source a name, AdventureWorks DW 2014. So now I have a database connected to. Now I need either tables or views for my data mining project. I'll right click the data source views and click New Data Source View. In the welcome screen, I'll click Next, and then the Select a Data Source shows me that I only have one data source in this project. I'll keep it selected and click Next. Now we're prompted for the views and tables to use in this data mining. The AdventureWorks Data Warehouse 2014 database has two views that help us with target mailing. The first one is vTarget Mail, and the next one is going to be the actual items that we want to use to predict later on. After we select those, we're going to click Next. It'll ask for a data source name, and I'm going to call this data mining. Once we have a name, I'm going to click the Finish button. It's going to view those two items for us in a data source view. We'll close that for now and save the changes that were made. Next, we're going to right-click on Mining Structures and create a new mining structure. At the welcome screen, we'll click Next, and it's prompted for selecting a definition. We can either select from an existing database like we have already picked in our data source and data source views, or from an existing cube, which actually changes the wizard as we step along. We're going to keep an existing relational database and click Next. It's also going to prompt us for a mining structure. When going through this wizard, you can only select either one mining structure or create a mining structure with no models. We're going to use Microsoft Decision Trees because we're using a predicting model. We'll keep that selected and click Next. Next, it's going to ask us for the data source view, and in this case, we only have one view to select from. Now we need the input table for our model. This part of the model is what we're actually creating the prediction on with test data as well as validated data. Our vTarget Mailing is the case that we're going to use. Now, before we continue, I'm going to launch SQL Server Management Studio. Once this comes up, we're going to actually connect to this database and see what this view looks like. I'm going to drill into Databases, AdventureWorks, DW 2014, and Views. I'm going to right-click vTarget Mailing and Script View as a Create. And what we'll see in this view towards the bottom is that it's actually joining the customer dimension with a select from another view called VDM Prep. So let's look at what VDM Prep is about. We'll right-click that one, script it as a view, and we'll scroll down to the From clause. Here we can see that what it's doing is grabbing fact internet sales line items joined with our date dimension, our product dimension, and then the product is joined to subcategory, subcategory to category, and then we have the fact internet sales joined to customer, geography, and sales territory. So what this view is doing is flattening the data into individual rows for a customer. But first, the view is going to join our fact and dimension tables to get some of the attributes we need to predict this data. You can see case statements that actually grab the age of the person at the time of the sale, which is this case statement, and also a case statement to kind of group income levels into low, high, and moderate. We also see that a category and a product name is chosen, as well as the customer key. The customer key is important because this is going to be the key in our mining model. Let's go to the other view create statement and see what it does with this table. As you notice, the customer dimension is joined with this DM prep. It's also grouped by customer key, region, and age. That is giving us the sum of if a bike was bought than if it wasn't bought. So as you can see, the inner select is a group by of customer, region, and age, and it's summing a case statement to see if the category was bikes or not bikes. This is how we get the column bike buyer that's either 0 or 1. That's our predictable column. We'll also see further up in the select that it's going to be joining or actually selecting most of the customer information along with that region, age, and did they buy a bike. We're not concerned about sales. What we're concerned about is if these were bike buyers. Also, you can see the different keys that are part of the dimension structure, as well as the demographics that we're going to use in our predicting model. We'll minimize this. Before we minimize, we can actually do a select on here and see what data is returned. Here we'll see that customer key and also the demographics, as well as the column that tells us if it's a bike buyer with the person's age at the time of the sale, the region, and even a commute distance. We'll minimize Management Studio and go back to our data mining wizard. So we selected as the case table the V target male. We'll click next in this wizard, and now we're giving the information that was pulled from this view. The first thing, if you notice on the bottom, it says no predictable column is defined. So what we have to do is find bike buyer and say that is the predicting column. Once we do that, you'll notice that the suggest button becomes available. I'm going to click on the suggest button, and what this mining model actually does is it goes through the data as well as the attributes and finds the significance of attributes related to if a person is a bike buyer. And you notice it sorts it by score, and you can see on the bottom there's some things that don't have any relevance to selecting a bike. What you can do here is click as input. You see age is selected, so apparently that's the most relevant column to predict on. But we can also tell it to select some of the other ones. We don't want French education, but we do want English education, the commute, children at home. Address line 2 would not matter in ours, so we skip down to yearly income, region, English occupation, marital status, gender, owner of a home, and that's it. Once we select the ones we think we want to do an analysis on, we click OK, and you can see that the input column now has been selected for those. The mining model selected customer key as the key value because it saw its uniqueness in the data. So this wizard does a lot of things for you, including helping you determine what is needed in a mining model. The last step in this window would be to select some of the attributes of a customer that we do not want involved in the prediction, but be able to display or drill down to. Here we'll select address line 1, and you notice none of the 3 columns get selected when I do that. We'll also pick some more information about the customer, like email address, first name. We'll scroll down a little, get the geography key to join if we need it, the last name, and also the phone number and a suffix and title for that user. We'll click next, and now we're given a list of those attributes. It is going to look in the attributes to determine the data type. Here you see data types of text, long, and double. Double is the yearly income, which is continuous. Now it tried to determine this as best it could, but there's another button down in the lower right that detects the continuous and discrete for the numeric columns. If we click that, you'll see some of the items have changed from continuous to discrete, like the bike buyer. You'll also see that total children changed to discrete, whereas yearly income kept on continuous. If we roll down this list, we'll see a couple other options as well. The data here does not seem to display anything in a cyclical fashion. A cyclical fashion will be something like month and year, where you have cycles of sales. For instance, every 6 months the cycle changes. So you can actually pick a different content type if you'd like. Another one is called discretized. For instance, age is continuous, but really we want it discretized, which means it's going to create bands of our age. Once we select that, we'll click next, and it's given us an option for creating the test data set. You have two abilities here. One is a percent of data, and the second is the maximum number of cases. If 30% is less than 1,000, then it'll use that for our test cases and leave the rest for validation. If 30% goes over 1,000, then the limit 1,000 will be kept. We'll click next on the screen and give it a name. We'll call this TM Bike Buyer. And the model, since it is a Microsoft decision tree, we'll call it DT Bike Buyer. Now we're finished, and we're going to click the Finish button, and we get the data in here, but it hasn't been processed yet. So once we right click on the mining structure and click Process, it's going to ask us to first deploy the project to a server. Once it's deployed, then we can actually process the data. If you're not sure where it's deploying to, you have to go back to the project and look at its properties. The project was deployed, and now it's ready for us to run the actual model. We'll click the Run button, and it'll give us a progress on what's going on. It'll tell us what it's doing on each individual attribute, how far along it is, and eventually it'll get to the end. Once we click Close, once this is over, and close again, now we have a mining model created, which we can view under Mining Models and also Mining Model Viewer. The Mining Model Viewer will give us a graphical representation of what we just deployed. Here we can see that the all is the top tree level, and then others below it will show different variations of what the mining legend will tell us about the data. Here you'll see of number of cars owned 0, 1 meaning he or she bought a bike, has about a 63% probability. We will get more into this viewer later on in the section, but here we wanted to show you the simplicity of creating a model and also the steps along the way in a wizard of how easy it is to create a model. As we dig deeper into data mining, we're going to look at adding additional mining models to the existing project that we've created. Once we have this first project created, it is now time to start adding some other prediction algorithms. Here we can add new mining algorithms and deploy and preview the results side by side. The ability to add filters to copy data or mining models can help marketing target specific customer sets based on the demographics or more than one demographic. Drilling into the data at a more detailed level will help process more detailed information. The users of these models are definitely going to start asking questions, and they're going to want more detailed analysis if the current model has an insufficient prediction. The accuracy chart will help with satisfying their need to see if the model is actually working. We will take the testing data that was excluded and compare the model created with the results with each other, and you're going to get a display which is called a lift chart. There are other reports to help with the accuracy of these models. You can compare their percentage accuracy to see which one is best. From the mining structure, we're going to go to the Mining Model tab. From here, we can add additional algorithms with the new Mining Model menu choice when you right-click on one of the existing models. The choices will be the ones that can be associated with the original algorithm selected for this model. In the case of decision tree, we can add the Microsoft cluster mining algorithm. This model will cluster categories or buckets of related attributes to the predicting column. It will help the user with the relationship between data groups. Naive Bayes uses the classification of categories for mining models like decision trees. It is based on Bayesian statistics that attributes have independence, and that is why naive is used to describe it. In this case, the yearly column will not be able to be used because of its content type of continuous. There are requirements for each algorithm, and they have to be abided. After adding, of course, we have to deploy and process before anything can be observed. Next, we can review the different models that were added. We will review the cluster algorithm now. Each cluster will be given a % of significance at predicting the column. You can see this by hovering your mouse over one of the cluster names. The shading variable will need to be changed to the predicted column value if it's not already selected. So in this case, we selected bike buyer instead of population. The state is the value from a drop-down that is selected for the predicted value. And this is where we are looking for bike buyer to be 1. If it was 0, that meant the person did not buy a bike. And the other option is the missing value as well as all values. If you're predicting, you want to select the state to that predicted value. To the left of the display, we can use a slider to show all links by going up or show less relevant clusters by sliding down. There's also the ability to rename the cluster. Like in this case, we can make cluster 10 the high bike buyer and one of the other clusters that's less shaded the low bike buyer. This helps with the other displays in the other viewer tabs. The Cluster Profiles tab will list histograms for all the attributes in each cluster that is found. This is a really useful option. As you can see in the lower right, the mining legend will give you these ranges like of ages and the actual distribution of the data at the intersection of that cluster. The mining legend is a great way to look at each histogram. You can also sort rows by clicking on any column heading, and there is also a drop down to select the most relevant parts of the histogram. The Characteristics tabs will enable you to select a cluster from a drop-down and get the variable with the greatest significance of predicting desired outcome. And in this case, for the all population, house owner being value of 1 has the highest probability. The Discrimination tab lets you compare two clusters. Like we could select the high and the low, and we could see what variables favor the predictability of that particular cluster. Now let's look at a demonstration of adding additional algorithms to our current mining model. First, we'll launch SQL Server Data Tools. Once the application is successfully launched, we'll go to the File menu to Recent Projects and open up our data mining solution. Here, we're going to double-click the mining structure, TM Bike Buyer. Once we have that open, we're going to go to the tab that says Mining Models. and here we can see our decision tree is the current only model. We can right click on that and add a new mining model and give it a name. Here we'll call this one Cluster Bike Buyer, and we'll change the algorithm name to Microsoft Clustering and click OK. It'll select the existing column values that the original decision trees has. Let's add 2 more. We'll right click, create a new mining model, and pick the naive Bayes, give it a name, and click OK. The reason we would add additional mining models is we want to see the percent that it is probable that it predicted the right outcome. And by selecting more than one model, we'll be able to see this. We get a message here that tells us that yearly income, because it's a continuous content type, cannot be used with this algorithm. If we click yes, it'll actually take that and change it to the ignore. We'll add one more model to our existing, and then we'll process the whole mining model again. We'll pick neural networks and give it a name and click OK. Next, we'll right click on the project and deploy to make sure our whole solution is deployed. This is a database in Management Studio on the Analysis Services service. And it's just like a cube and a tab contained within a database. When you deploy and process, you can actually deploy cubes with the mining structures as well. There might be the case where you want to separate this information so it can be backup and restored separately, or one doesn't tax the other in processing. So since our solution is deployed, we're going to right click on one of the mining models and select the menu choice Process Mining Structure in All Models. It says it's out of date. We'll click yes to update any information it doesn't have, and we're given the Processing Mining Structure window. Here we can look at an impact analysis or change the processing options, but what we're going to do is just run this mining model. Actually, it's multiple mining models now, and it'll give us a progress on each one, and we can see the amount of actual rows being used, and it looks like some of them in the neighborhood of 17,000 rows. You can see there's iterations for the different types of models because they all take different type of processing. We could even drill in to see more details, and there's even a view details buttons if we wanted to. Once it's all finished processing, we'll click close and close again. Next, we can use the mining model viewer to look at these new mining models. Again, it thinks the information's out of date. We'll refresh it, and it'll actually process the viewing. Here we see the decision tree, but in the mining model drop-down, we could change that to cluster. And once the clusters is processed, we'll see the most relevant ones. They're shaded in a darker color here to tell us which is the most relevant cluster. In our shading variables, though, population, which is an attribute, is selected. We'll change that to bike buyer and change the state to 1. So what we want to see is the clusters that are most relevant based on someone buying a bike. If we hover our mouse over it, we'll see that cluster 10 is at 70%. We could rename this cluster as high bike buyer. And now in the other tabs in the viewers, that'll be more relevant. There's also a slider on the right to show the significance of these clusters. And once you go down, you can see the actual lines that show the related clusters in this mining model. So now that we have bike buyer highlighted as high, let's go to cluster profiles and actually find that particular one. Here it is to the far right, and I'm going to pin the solution just so we see the mining legend here. Now the high is to the right. We can also hide some of these columns so we can get that particular column displayed well. And you see number of cars is the one selected, and you can see that 1 for this particular cluster is the only one that has a distribution. We can sort these columns by clicking on the column heading. In this case, I'm clicking on variables. We also have the ability to show different clusters in the view. And we could pick which one we actually want to see. Let's go to the next tab, which is cluster characteristics. And we can see that house owner 1 has the highest probability, and its probability is around 67%. We need to change our cluster to the high bike buyer to see that number of cars owned 1 shows 100% probability of buying a bike in that cluster. The last tab, cluster discrimination, lets us select two particular clusters and compare them. And we can see that the number of children in the house, number of car owns, and total children's has a high probability for a high bike buyer. But in cluster 2, the first thing that pops up is yearly income. We can also change the mining models to the naive Bayes, which will ask us to refresh it, and it actually displays things very similar to the clustering, where in the middle we see the attribute that is selected. To the left, the slider lets us remove the less relevant attributes on buying a bike. There's also an attributes profile tab, like the clusters, a characteristic, as well as a discrimination. So you can see presented to the user is a lot of information. The last one is the neural networks, which has a different display than the rest. And what you'll also notice with any of these is under the viewer, there's always a Microsoft generic content tree viewer, which actually shows you the text values of each of these predictive models. So you can actually look to see what the values are by drilling down in the left on the different predictabilities.